Designing a media solution is one of the other objectives. I'm not going to spend a lot of time on this, but essentially it's just all about building up a media solution using media services. Media services is a combination of quite a few different services. It's all about just building like really scalable media management delivery solutions, where it includes uploading videos, encoding videos, driving data from those videos, mining data from those videos, packaging them both pre-packaged, just-in-time packaging, on-demand video streaming, live streaming, allowing you to look into live streams, so many different features. And the great thing about media services is a lot of this is out of the box when you use media services. But if you want to really go down to the rabbit hole, you can actually develop your own custom workflows and go well beyond what's provided out of the box. So let's look at another sample question. Here, you're an integration developer for Blue Yonder Airlines. That's your context. Blue Yonder has deployed their latest web application to Azure App Service. You are tasked with integrating that new web app with a legacy WCF service that must remain on-premise. Blue Yonder wishes to do this without opening any new inbound ports on their corporate firewall. So, your goal here is, which solution should you select? So you got to select the appropriate option in the answer area. So we want to integrate with a legacy WCF service, but we can't open any new ports. So that cuts out what? API app, API management. I don't even know what WebJobs is doing in this list. So it's really easy. We'll just isolate this down to service bus because we can use a relay and we're pretty good there. Now that we talked about some of the other solutions, let's talk about how we could design an advanced application in Azure. Now, advanced applications cover a large scope in this objective. And so one of the things as a developer or architect you may have never touched, or even IT pros moving into architect, you may have never touched is HPC. However, HPC is called out in this objective. So I just want to take a brief moment to talk to you about HPC options in Azure. So you can use the Azure Batch service, which is basically HPC as a service. Or you can use some of the existing HPC tools. Specifically, I want to call out HPC Pack. Now, HPC Pack uses RDMA to implement high-performance computing between virtual machines. If you're not familiar, RDMA, or Remote Direct Memory Access, is a hardware-level implementation. It kind of behaves like another NIC, a network interface card. And essentially, the RDMA connections are much lower latency than traditional network connections, and they basically skip past all of the other network tiers when you're making a traditional network communication request. And so very low latency, and to the applications, it may seem like they're sharing memory. At the end of the day, it's still a networking option, but it's a little bit interesting implementation. So you can only do these with A8 or A9 VMs, and you can definitely use this to implement an HPC scenario. You can do this with virtual machines. You can do this with worker roles. There are some HPC services where you can actually do this using Windows VMs, Linux VMs, a lot of scenarios here. When you're doing HPC rollout in Azure, you can do it in 3 different ways. And it's not, all-inclusive list, but you can do a parametric sweep, do everything in Azure exclusively, basically stand up your whole HPC infrastructure in Azure. Or the one that I want to really call out here is a hybrid solution with on-premise. So let's say you have an HPC rollout on-premise using HPC Pack, excuse me, and you have HPC Pack, your VM's on-premise, you're running a high-performance compute job. Maybe you're trying to crunch some numbers for researchers. And your existing infrastructure can't support the type of tasks you need to do, and a time is reasonable for your researchers. By the time they get this information, it'll be useless. So you can burst to Azure. What this means is you can stand up VMs, or I've seen this done with worker roles before, and essentially you create them temporarily to just offset some of the workload. So spread the workload around on these VMs in Azure, along with whatever infrastructure you're using. Get the computational tasks done, and then spin them down. So it's a burst to Azure because it's temporary. Again, another way you can do high-performance computing using Azure. Now, for long-running applications, essentially, we talked about WebJobs, so the only thing I wanted to call out here is worker roles. Worker roles are really good for long-running perpetual asynchronous tasks where you don't need any user interaction or input. Input may come in from well, it's not really input. The way they receive data is they poll or receive it via some type of asynchronous endpoint. But the idea here for worker roles is that they could test the queue, they can use any other type of communication mechanism to determine if there's any work for them to do. And they're just long running, and they're asynchronous by their design and nature. Your web role gets out of the business of doing long running compute, and it sends it off to worker roles who can do this. So this allows you to design stateless components. You can route requests to your web roles. It makes things really simple and really easy to follow. And worker roles, web jobs can both do this. Big difference between worker roles and web jobs. On the web job side, they support a lot of different languages, a lot of different options there, a lot of scripts. You can do a lot of things there on web jobs. Worker roles, they're just VMs, so you can install almost anything on them. If there's something you need to install, like a GDI Plus component that does PDF generation, you can do that. Web jobs support some subset of GDI functionality, but it's not. You can't install anything on a web job like you can on a worker role. So those are the things you need to take into consideration as an architect when you're trying to decide between these two options. When you're talking about storage, you want to think about selecting appropriate storage options for your scenarios. You want to consider performance. If you're doing development, you might want to consider queue-centric pattern. And then when you're using VMs or cloud services, you want to think about how they interact with storage services or external resources such as SQL database. So for example, VMs interacting with storage service. If your application logic is accessing storage, where is the storage for the actual VHDs going to live? If your VM's interacting with SQL database, is it Azure SQL database? Is it SQL database on SQL Server, standalone, hosted on an Azure virtual machine? What ports do you need to open? There's a lot of things you need to consider here. I want to talk to you about a couple things with storage options, and the first one is the queue-centric pattern. The competing consumers pattern, this is available in MSDN and a Cloud Patterns Guidance, is a very general pattern talking about how we can asynchronously separate long-running compute tasks from our application front ends, whether they're a web front end, desktop front end, mobile device, IoT device, whatever. So these application instances are generators. They generate messages. So let's use the example of we're a website and we're hosting images and we need to create thumbnails whenever somebody uploads an image. So user A goes to our website, uploads an image of maybe their vacation, and we need to generate a thumbnail. Well, we don't want the web application to do that because the web application needs to receive this image and move on to another user. So we put this image maybe into storage. So a storage blob, we put this image in there. Now we put a message on a queue, whether it's service bus, storage queue, that's really up to you as designer of the application. And we say, all right, somebody else is going to create the thumbnail. Web application, move on to the next user. So a web application minimizes the amount of overhead involved with long-running tasks, frees up a lot of threads, make everybody happy. Now this queue has all these requests to generate thumbnails. When we say competing consumers, from a diagram perspective, the consumers is referring to a pool of instances that actually pull messages from those queues and does some logic based upon them. So it might pull a message from the queue and generate a thumbnail. It might pull another message from the queue and generate a thumbnail. If an instance goes down, another instance will spin up and generate them. If it's a priority to generate these thumbnails quickly, we'll create more consumer instances. If we're the type of company we say, look, if it takes 15 minutes to generate a thumbnail, it's fine. We might just spin up 1 or 2 consumer instances and say that's good enough. If we ever have a promotion where we know a lot of people are going to be uploading images, we might go up to 15 consumer instances. So it seems really fast for the new users coming in. They're like, oh yeah, this is wonderful, wonderful, great. That's a competing consumers pattern. We can scale up and down on both ends, and they're asynchronous, so they don't affect the other. We can scale up the web app to handle more users who are viewing images but not uploading, and scale down the consumer side. Or we can scale up the consumer side and scale down the generator side if less people are visiting the website looking at images, but a lot of people are uploading images. Maybe we have a promotion where if you upload an image and we select your image, you'll win a trip to Paris. And all of a sudden, not a lot of people are looking at images, but everyone's uploading them. So we get to scale them separately. That's the big thing about the competing consumers pattern. We get that option. It's not something if they were all locked together in a single application we could do. Another pattern I want to talk to you about is the valet queue pattern. This one's a little bit simpler. I know I say a little bit simpler, but the diagram looks more complex. But this one's in 4 pieces. So the idea here is that whenever a user requests a resource, we actually go to a storage account, go download that resource, validate the user, and then return the downloaded resource as a string to the user. You've probably seen a lot of applications that do this. However, this is wonderfully inefficient because if you've ever had a parent who you said, hey mom or dad, can I get a cookie? And they say, oh yeah. All right, well, are you going to get the cookie for me? No, you can go get your own cookie. Well, that's what the valet key pattern is go get your own cookie, but for applications. So the idea here is for the valet key pattern is we as a user go and request a resource. The application validates our request that we can access the resource. That's the parent checking whether or not we can have a cookie or not. Maybe we've had too many, maybe we haven't had one yet, maybe we ate dinner, maybe we haven't eaten dinner yet. They're validating our request. If our request is valid, they'll go and give us an access key that gives us the right to get that resource. So they'll return the access key to us. And then we as a user will go get that resource on our own. So in the context of a web application, the user will say, I need to download the image of a bridge in Texas. And we'll validate that the user has the right to download that image. So we might validate them against authorization logic, business logic, whatever it may be. And our application will go to the storage account and get a SAS token so that they can download that image. Then the application returns that SAS token to whatever web front-end application they're using. And then from the web browser point of view, maybe we'll do a 301 redirect. Maybe we'll do some other type of logic, something in JavaScript. But essentially, we're letting the browser go and download the image. So our application, as soon as it gives the token, it's completely out of the business of managing this request anymore. The users download the image themselves. That saves down on bandwidth, that saves on overhead, saves on a lot of things. Both the competing consumers pattern and the valet key pattern are available on the MSDN Cloud Patterns guidance site. Let's talk about integrating other Azure services in our solution. This is again listed in our objective domain, and it's really, we have a couple of these in the architecture exam, and it's all about just saying, hey, look, you have to use a lot of different Azure services to compose a solution. So be aware of all of them. You don't have to be deep on each of them, but just be aware of what they are. So in this example is 4 services. Machine learning allow us to actually do predictive analytics based upon a set of data. Big data, basically understanding what HD Insight is in the context of Azure. How we can set up clusters, whether they're Hadoop, whether they're Storm, Spark, set them up in Azure, analyze, ingest, process, store data. Media services, which we talked about earlier, just all-inclusive solution for streaming, encoding, doing analysis on data, storing data, securing it dynamically or statically packaging it. And Azure Search, which is really about providing a search engine over top of a set of data. If you don't want to implement your own search engine, you can use Azure Search as your search engine, ingesting whatever existing data you have. So let's look at another sample question. Here the context is that you're an operations engineer for Parnell Aerospace. Your department is using high-performance compute and RDMA to run its most computationally expensive programs for the staff researchers. You have been tasked with selecting appropriate virtual machine sizes for the infrastructure in Azure. So which sizes could you select to support your requirements? To answer, select the appropriate 2 options in the answer area. So I can tell you right away that A11 is not an option. It supports high-performance compute, but it does not support RDMA. And D2 is not an option because it supports neither. So we know A8 and A9 supports RDMA. But I did want to add this question because the new N-tier VMs support RDMA too. That's the NVIDIA-driven GPU series of virtual machines. They also support RDMA, so they can support computationally intensive tasks. In this next objective, we're going to talk about web apps and how we could design them in our architected Azure solutions. These next couple sections are a little bit briefer than others because they have a smaller percentage. And it's because there's less of a delta between what you might know today and what you need to know for the certification exam. From a web app point of view, there's many different ways we can store web apps. We can store them, or web applications, we can store them in Azure App Service as a web app. Instant deployment, we can do SSL, custom domain names, all configuration settings. We don't have to do a lot of heavy lifting here. We can use WebJobs for background processing. We can scale to larger machines. We don't have to redeploy things to scale. It's really useful for us. Web apps is a very low friction lease management solution. From a virtual machines point of view, we can set virtual machines into using load balancers so that we can have resiliency across different VM instances. If they're in availability set, we can actually go and make sure that they're load balanced too, so that if there's an update or a fault, they'll fail over to the other virtual machine instances as opposed to our application failing outright. From a cloud services point of view, we still get that load balancer, but we don't have to actually go configure it like with virtual machines. And we still get background processing with worker roles. We still get front-end logic like with web apps, with web roles. It's just a little bit more management on the cloud services side. From a deployment of web apps point of view, the big thing you want to know is they can deploy whether you're in continuous delivery with Visual Studio Online, GitHub, Mercurial, Bitbucket. You can use whatever version control you want on those for that. You can even remotely do continuous deployment from an external repo if you like. You can deploy using Web Deploy, either directly using PowerShell, grabbing a Web Deploy package from IIS instance and doing Web Deploy deployment, or from Visual Studio, whereas if you right-click and deploy to a web app, behind the scenes it's doing Web Deploy for you. You can do an FTP deployment, which is exactly what it says, deploy files via FTP. And then you can deploy directly to your production slot, or you can create additional slots in your app service, web app, API app, mobile app, logic app, or not logic app, API app or mobile app, because both of those are backed by a web app. The idea here is that you can create a development, QA, testing slot, and do your continuous delivery to those slots. Allow people to validate that the application works in those slots, and then swap the slots and allow people to switch the code to production, switch your earlier production to that whatever that previous slot or the source slot was. That way you can test the application out, validate it works, and then send it to production. As far as business continuity and web apps, a couple things we can do. We can scale up and out. Essentially, from a web apps point of view, we can create more instances. We can change the size of instances. From a SQL database point of view, we can switch tiers and levels. We can use features such as Elastic Scale. Azure SQL Database has high availability pretty much built in. From a disaster recovery point of view, Azure SQL Database allows us to do a couple of interesting things. We can actually have a secondary region with read access to that secondary region if we want, in case there's a data outage in primary region. We can replicate across these regions. The idea here is that there's a lot of HA options built into SQL Database web apps. Usually by the time you get to architecture tier, you know a little bit about them. So as far as this exam is concerned, you really want to think about them as bricks, and you want to connect these bricks together and lay these bricks together to compose a formal solution. So instead of thinking about app service continuity, VM continuity, and SQL database continuity as different siphons, you want to think about how you will compose these together to build a full solution. A really good example I always give is if you look online, you'll see on Azure.com, MSD, and documentations examples of deploying SharePoint architecture to Azure. SharePoint is a really good example because it composes a lot of different tiers. A database tiers with VMs and SQL database, a web front-end tier, application logic tier, and then you will also deploy an AD box for that tier. And so you have to design for high availability business continuity by default. You don't want any of these tiers to have a single VM. So you're now thinking about availability sets for each tier, multiple VMs for each tier. SharePoint kind of forces you to think about business continuity for your web solutions. So let's look at a sample question for this section. The context for this question is that you're a developer for Fabricam.net. Your production web application is hosted in Azure App Service using a web app instance. You need to host the latest versions of the application for your Q&A and test teams without affecting the latest production deployment. So which web app feature would you use? So we're only selecting the single option. We want to make sure that we have a different instance of a web app for our QA team, for our test team, but we don't want to affect the production instance. So almost immediately based upon what I said earlier, you're going to go to deployment slots. This allows us to basically create other web apps that are related, but they're essentially separate enough that we can deploy to these deployment slots without affecting the production application. Now we're going to talk about the last section, which is designing a management, monitoring, and business continuity strategy. There's a couple things I want to cover here. The big one is about hybrid architectures. Virtual machines compute on-premise, virtual machines compute in Azure. There's a lot of things that have to be shared. Virtualization, management, development, data platform, identity, all of this has to be shared across these different scenarios. And so we have stuff on-premise, stuff in Azure. How do we manage this? Well, System Center allows us to manage these resources. And System Center is composed of many different parts. We have the configuration manager, which is really just about configuring applications, client devices. It's configuration. We have operations manager, which is really our monitoring tool. It allows us to set up alerts to let us know when things get outside of predetermined thresholds. Monitor solutions from a forest from the trees perspective across a whole hybrid deployment, not just in Azure, not just on-premise. We have a virtual machine manager if you want to actually manage your data center and actually manage the VMs in your data center. There's others, DPM, Orchestrator, all of those available in System Center. So System Center is really good for hybrid scenarios, whether you're doing a private cloud, whether you're using a public cloud such as Azure, or using a cloud as a service provider or co-located facility. The idea here is that System Center will allow you to see all of your resources at a much higher level than each of these individual providers. So when we think about monitoring, we want to come up with a strategy for monitoring. So a lot of these services we use, like cloud services, web worker roles, app services, web apps, they already have built-in diagnostic capabilities. They have charts, diagrams, logging. We can throw all this stuff into storage. So they have built-in capabilities, and we can enhance this with System Center. So System Center has management packs for SQL, actual SQL Server standalone, Azure SQL Database, and Azure Compute itself. So we can use these management packs to extend the built-in abilities to give us more information. We can bring in open source tools from third parties, or we can bring in other tools such as Application Insights for Visual Studio Online, New Relics for telemetry, Operations Manager from the System Center point of view. And then we can use this in a scenario where we can extend and basically, almost like a plug-in model, we're going to enhance what we're monitoring. Monitor more, get more information. So monitoring, you have to come up with a strategy for it. And that's what this objective is really all about, is saying, hey, know all the different components of monitoring so that if we say we need to monitor for X or we need to monitor for Y, you can say, hey, we would use this component, or hey, we would use that component. That's what really design a monitoring strategy is all about, as an objective. Disaster recovery strategies is pretty similar. You need to know what options you have for DR. Once you know what options you have for DR, it's easier to design strategies because you can pick the appropriate option. So whether you use a Hyper-V Recovery Manager to recover Azure deployment to on-premise or on-premise deployment to Azure, whether you use a Microsoft Azure Backup, which integrates with Windows Server Backup, what if you're doing a recovery strategy using Store Simple? I know a lot of people see Store Simple as a way to make data access cheaper, easier to manage, but it's also a DR strategy. If you have data that's being replicated to the cloud, it's now available if something happens with your storage on-premise. Of course, over top of all of this, you have simple backup solutions, but then you also have System Center DPM, which is really just about, backed up data stored in Azure, whether it's, physical VM or Azure VM. DPM is kind of like a superset of as far as what it can provide, a superset of features that each of these individual services would provide on their own. So a lot of different options here. Hyper-V Recovery Manager is really about orchestration recovery. Azure Backup is literally just backup. Store Simple is about your actual files, your files data, this on local SAN, and you want to push to Azure storage. DPM is just a level of abstraction above all of that. So let's look at another sample question. Here, you're an operations manager at Woodgrove Bank. You need to monitor your infrastructure deployed in Azure using System Center and configure alerts when any virtual machines are in an errant state or their properties are beyond pre-configured thresholds. You probably already heard me say that phrase, so you already know the answer. Which System Center feature should you select? To answer, select the appropriate option, singular, in the answer area. And that's going to be operations manager, because you probably heard me say pre-configured thresholds already. So that ring operations manager, because we're monitoring, we're setting alerts. So let's talk about some of the study resources that can help you with this exam. On Azure.com, there are learning plans that are available that gives you a visual depiction of what you need to do to master a certain topic area. So it's a collection of articles, demos, tutorials that you can walk through to achieve a much higher level of understanding for a service. Even if you think you know a service, I would recommend looking at the learning plan for that service. And from our Azure Architecture exam point of view, the big thing you want to think about here is knowing these services well enough that you can always identify the right one based upon your business context scenario. So that's virtual machines, site recovery, Azure Active Directory, Azure Automation, and SQL Database are all featured learning plans on Azure.com. So I would recommend that you walk through each of these learning plans. You might notice one there sounds a little off, Azure Automation. Now with Azure Automation, even though it's not really caught up that much in this exam, it's more related to the IT Pro exam, Azure Automation Learning Path does cover some of the things you can do in PowerShell as far as automating management of your services. And these are things you're going to want to know as an architect to know what options you have from an automation perspective available to you when you're architecting these solutions. Because you do have to deploy these solutions, you architect, and that's one of the things you do want to know for this certification exam. Microsoft Virtual Academy does provide some incredible resources for you to help study for this exam. There's an Architecting Microsoft Azure Solutions MVA session that covers this exam specifically. There's also, and this is one of my personal favorites, Azure Solution Training. It's training for sales professionals, but sales professionals tend to think of things as forest from the trees. So we're looking at the services as blocks and telling them what services does what so that you can propose solutions to clients. Fortunately, as an architect, you're doing the same thing. So why not take the sales training? Sit through there, look at a high level what each service does, because you need to compose solutions. You notice a lot of objectives about composing strategies and solutions based upon different services. There's also an Azure IaaS Deep Dive Jumpstart that goes a lot deeper than the 533 certification exam that I recommend, because it covers a lot of architectural concepts. And from a developer and data perspective, there's Polyglot Persistence. That's an MVA session that covers combining different data services for really unique and useful scenarios, which you couldn't handle with just a single data service, or at least couldn't handle effectively. So these are the MVA sessions I recommend. As far as other resources, there's a Microsoft official courseware for the other certification exams, but not for 534. 20532 and 20533 have Microsoft official courseware. For 534, there's an edX course called Architecting Microsoft Azure Solutions that's available to you. So I always recommend, if you're going to take this whole certification path, to just take all of the mock that's available, or Microsoft official courseware that's available, and combine it with the edX courses. There's a Microsoft Pressbook to help you study for this exam, and there's Microsoft official practice tests for each of these exams. On top of all of that, you have Born to Learn that has forums and exam prep wiki to help you prepare with other MCPs who would like to earn the MCSD in Azure Architecture. So in review, we cover quite a lot in this session. We talked about infrastructure networking, security, storage data access, advanced applications, web apps, and business continuity. Hopefully this session helped you prepare for the architecture exam, and I look forward to seeing you as a certified Azure Solutions Architect, and you can help me build out some of my solutions. Thank you.